When a trader clicks a button in New York and an execution confirms in London, human perception tells us it happened instantaneously. To our brains, both events occurred at the exact same moment. But look closely at the physical infrastructure, and that illusion shatters. Data is not magic, it is profoundly physical. It travels as pulses of light through thick underground fiber optic cables, like the ones you see here. The sheer physical distance between two cities guarantees a delay in transmission. This physical delay gives birth to latency arbitrage. High-frequency trading firms position their computer servers as close to the exchange as possible, intercepting market data a fraction of a millisecond before a distant signal arrives. Because now depends entirely on where you are geographically standing, the market operates in structural chaos. The system rewards whoever controls the shortest physical path, leaving everyone else exposed to exploitation. Wall Street attempts to organize this traffic using localized digital clocks housed on individual servers. There is no single, unified master timekeeper for the global market. Without a universal physical anchor, independent server clocks drift out of phase. This mismatch creates tiny, overlapping blind spots in the timeline. Predatory algorithms live inside these vacuums. They sit in the dark spots, reading your trade orders before the market knows they exist. Firms spend billions trying to outrun this vulnerability, continuously laying straighter cables and building faster processors in a never-ending arms race. But you cannot fix a structural flaw with raw speed. The underlying issue is that the measurement of time itself is relative. As long as digital time remains relative, any trust in market fairness is an illusion. To fix the market, we must redesign how systems measure time from the ground up. To find where the exploit ends, we have to look past human seconds and machine milliseconds. We have to drill all the way down to the fundamental baseline of the physical universe. That baseline is Planck time, roughly 5.39 times 10 to the negative 44th seconds. It is a constant of physics, representing the absolute limit of reality, where time cannot be sliced any thinner. This brings us to a protocol known as FTU Spec version 1.7.1. It defines the Fady tempo unit, or FTU, establishing a reproducible baseline tick anchored directly to Planck time. Unlike the drifting, localized clocks bolted to Wall Street servers, the FTU is not subject to geographic delay or hardware lag. By tethering the measurement of time to a law of physics, rather than a human-made server, time ceases to be relative. It becomes an absolute, universally consistent foundation. To apply this physical constant to actual finance, the specification uses a formula called the Gulf law, which binds the incoming stream of chaotic market data directly to the FTU's quantum tick. Instead of trades racing through cables, the Gulf law freezes the market. It catches chaotic data points, snapping every event into alignment across a universally synchronized grid. Every pulse is assigned an unforgeable sealed timestamp. The microsecond vacuums are closed. Because the entire FTU specification is published as a sealed, machine-verifiable release on GitHub, the timestamp methodology is transparent. Cryptographic hashes and conformance vectors ensure the data cannot be spoofed. The latency loophole is mathematically resolved. Predatory algorithms are locked out of the market because there are no longer any gaps in time left for them to hide within. Under this architecture, your geographic distance from an exchange no longer dictates your success. Server location and fiber optic speed offers zero predatory advantage. The market transitions from a chaotic, hardware-driven race into a deterministic, level playing field governed by absolute financial physics. This transition is possible because every digital signal is effectively an oscillation. This is the axiom of frequency, the principle that material, energetic, and informational phenomena emerge from frequency. In this framework, every trade is simply a wave that can be precisely measured. By anchoring our systems to this axiom, the FTU becomes the standard for any high-speed exchange of information. We are no longer trying to sync different clocks. We are mapping all events to a single physical constant. This same synchronized logic scales outward to other systems that rely on rhythmic pulses. It provides a template for resolving data chaos in artificial intelligence, and even helps us model the frequency-based signals within biological systems. A moment of wonder. True trust in our human systems requires us to move beyond localized consensus. To build fair, incorruptible networks, we have to anchor our technology to the unbreakable, computable laws of the physical universe.